Welcome to this Business Finland webinar on smart mobility. This is the third webinar in our series for smart mobility. In the first one a few weeks ago, we looked at Finland and why Finland is a top location for automotive R&D. Despite the fact that we don't have our own car OEMs in Finland, we do have a large software cluster that works for the automotive industry. The second one in the series was a hugely interesting look at the cockpit of the future, where we had a steering wheel case that looked at the multimodal human-machine interaction. It was a 3D touch steering wheel where people who did the concept, they looked at user experience, novel materials, and even ways to manufacture these new parts of the car. Today, we have a hugely interesting, again, topic, mastering very long software cycles in automotive, updating the car over the air. These are Business Finland webinars. Business Finland is the Finnish government's innovation funding arm. Our role is to ensure the Finnish economy is thriving with innovative research and businesses that reach beyond the borders of our small country. Here in the US, we do this by reaching out to businesses and research organizations to find out if there are mutual interests for commercial or scientific collaboration. Before we go to the topic today, a couple of house rules. All attendees are muted, but you will be able to ask questions via the Q&A chat function in your GoToWebinar platform. You can type in your name and company when you ask the question, but it's not necessary. At the end of the presentation, I'm going to read the questions, but I will not read out your name and your company. That remains with us in case you want us to contact you further. The session will be recorded, and the recording is going to be made available to you, also to those who registered, but were not able to attend today. So, topic of the day, digitalization, connectivity, and especially advanced driver assistance systems, which are the self-driving capabilities of cars, are all becoming standard elements in today's cars. This trend had led to OEMs having to deal with the exponential increase of software content while attempting to keep the software development speed at a certain pace, so typical of the digital native companies. What are these methods digital native companies have used to reach their speed of development in increasingly complex software systems? Today we're going to hear from Markku Tamski. If you want to turn on your camera so we can see you. Markku Tamski is the lead software architect at TietoEVRY. He has a solid long-term experience in software and product development covering automotive, as well as smart devices and connected services. Nice to have you here, Markku. So I'm going to make you a presenter so you can start sharing your presentation. Excellent. Thank you. Go ahead.
Okay, thank you, and good morning, everyone, and welcome also on my behalf to this session. Today I want to talk to you about a major challenge that the automotive industry is facing right now, which is the very long-term software maintenance, or super long-term support as it's called in some activities. I'll describe the challenge, the changes that are causing it in the first half of my presentation, and the second half focuses on our experiences from a range of industries adapted to the automotive, describing what you can do to manage this challenge. My name is Markku Tamski. I am the lead software architect, as said, in TietoEVRY's automotive business unit. For the last 25 years or so, I've been working in leading edge software technology and product development in, for example, the mobile technologies, application networking, connected services, and automotive industries. And I've been lucky enough during that time to be able to work and gather first-hand experience from a wide variety of roles, from one end of the chain in the technology development and industry standards, all the way to the other in product software releasing. TietoEVRY is a leading digital services software company headquartered in Finland, and we employ around 24,000 experts globally. We have thousands of enterprise and public sector customers in more than 90 countries. And in our automotive business unit in product development services, we have around 400 automotive experts. And thanks to TietoEVRY's involvement in pretty much every business area relying on software today, we can pull these lessons learned from all these areas and see how they could be applied in automotive industry. Managing very long-term software maintenance isn't exactly a new challenge to the automotive industry. The industry has been using and maintaining software according to detailed processes for a very long time now. So why would it suddenly become a problem? And why not just do what has worked for all these years? The simple reason is that the software landscape in automotive industry is changing extremely fast. And it's changing in ways that are not a good fit with the existing practices. Now let's go through what's changing and how that creates the need for new and creative thinking. First, automotive industry must follow strict product liability laws. And that's not changing even with the introduction of new software-driven features. One such example is the FCA court case based on the famous Jeep hack that was described by Wired magazine in 2015. The case itself is still ongoing, but one thing that's clear from that is that in relation to liability and product safety, there is no distinction between software vulnerabilities and hardware faults. Probably the biggest change is the sudden explosion of software in and around cars. All the current major automotive trends rely heavily on software. There's connectivity, advanced driver assist systems, autonomous vehicles, electrification, for example, battery management in that area, and digitalization with all the new digital cockpit features. And then there's the various mobility services around the car. And you could add more, such as the new electrical architecture that all have just one aim, that there's less separate hardware units in cars by using more software. So estimates of cars with more than 1 billion lines of code appearing on our roads soon are no longer outlandish. They are actually quite feasible. So it's only natural that the automotive industry is turning to the so-called digital native industries to see how they manage to develop products with massive amounts of code. There are a few major transitions most of these industries have already made. One, they're building on top of and modifying existing common software platforms and technologies, even when those have not been purpose-built for this exact use. So Linux, Android via Linux and Java, iOS, Windows, they all have a very long lineage in this sense, as do, for example, IP protocols and web technologies. And two, they are ditching waterfall at least to some degree, and they are moving to more agile development methods. Agile can here mean pretty much anything in this context, but at least it hopefully means that the willingness to adapt to the inevitable changes during the lifetime of the software. The challenge with these learning from the digital native industries type of transitions is that both of these go against the strict process and certification based development in automotive industry. Some companies then decide to forego the traditional methods altogether, which of course, for example, Tesla does this, and follow these same ideas, whereas some others try to find the middle ground between the new ideas and the existing methods. Another driver for the software explosion and the need for much faster development speed is this digital lifestyle of the customers. The value of our products is compared not just to other cars, but to phones, smart TVs, and other parts of this digital lifestyle. Much of it is based on a fast evolving landscape of device-independent cloud services. So the users naturally expect to use the same services and subscriptions in their cars as they use elsewhere at any given time, not just when they buy the car. And another issue that needs to be solved related to this perceived value to the customer is the fact that today a new family sedan can have more modern features than a new premium category car, just because the premium model was brought to market earlier. So the one key requirement to solving these issues is secure, completely reliable over-the-air update capability. That needs to cover all the software in the vehicle, which of course requires connectivity. All cars will be connected cars. Updates require connectivity, but so do, for example, eCall and vehicle-to-vehicle features, selling vehicle options using software activation, and OEMs collecting and analyzing data from the vehicles to help with their business objectives. Connectivity uncovers a flood of security challenges. Hacking no longer requires physical access to the car. So all cars, all brands, all models are suddenly targets for finding vulnerabilities and developing hacks. And many of the hacks are going to be fleet-wide, not just limited to one specific car. So here we have a link back to the first item and the most critical resource to secure, the safety of the driver, passengers, and passersby. On the other hand, over-the-air updates are used to fix the vulnerabilities as well. So connectivity is coupled with both the problem and the solution. These changes to the automotive industry software landscape are the basis for why we need to change the way we do things. Now let's get back to where this whole presentation started, so meaning the very long product life cycle of, for example, 15 to 20 years. Looking back at the year 2005 shows us why the solutions from the digital native industries won't work as is either. In 2005, there was no Android yet, as we know it at least. The earliest currently supported version is from 2016. There was no iPhone, there was no iOS, and the earliest currently supported version is from 2015. Our PCs were mostly running Windows XP, and even the many times extended support ended in 2014. Linux kernel has had long-term support versions for quite a while, but even the longest one so far lasted just 7 years. Realizing this led to this super long-term support activity in Linux kernel development, which is also ongoing. And then there's the other part, the cost trend of very long-term maintenance. Some of these common learnings from the studies tell us that, one, maintenance cost will increase, and the cost increases will accelerate faster with every year of maintenance. This is due to the bigger delta between the original product software and any new work having been done after that. And two, the maintenance cost will also increase from one project to the next one, thanks to the increasing complexity of the software systems in general. As an example, in one of the studies, by 5th year of maintenance on average, the combined maintenance cost equaled the original development costs. Okay, so there's a lot of code in the car. It's going to be on the road for a very long time. It's highly connected and thus open for remote hacking, and the software is costly to maintain. There must be some other industries already solving the same issues, right? Unfortunately, this challenge to the automotive industry specifically does have a unique set of constraints and requirements, which makes it more difficult to manage. That doesn't mean that we are alone working with this, and common ideas and concepts can and should be reused and refined, most certainly should. But let's look at what creates this uniqueness in this maintenance issue for automotive. Here we have some of the characteristics of automotive and 2 other fields relying on software systems. These 2 have been picked on purpose from the opposite ends of the landscape. On the left, we have mobile devices. On the right, we have critical infrastructure systems, waterworks, waste management, electricity grid, power plants, and so on. And of course, you can see highlighted, you can see the automotive industry situation. There are millions to billions of cars to maintain, much like mobile devices. Cars are and will be highly connected with a wide variety of connectivity interfaces, again, just like mobile devices. Critical infrastructure, on the other hand, tries to keep the connectivity as minimal as reasonable due to security implications. Feature complexity of the near future vehicles is huge and growing all the time. On the mobile side, a lot of this complexity is due to the third-party apps, which may or may not become a big thing in cars, but cars will anyway have increasingly complex ADAS and autonomous driving systems with software. Physical maintenance access to cars and phones is still a possibility with recalls and garage days, but it's not really a feasible way to manage frequent software updates. The support period for phones, on the other hand, is usually anything from short to barely existent, whereas a critical infrastructure system lifetime may well be 50 years. And I would claim extending the support from the cars 15 to 20 years to 50 years in critical infrastructure is a much simpler process than going from 6 months to 20 years. Also, the product liability and safety processes in cars are much closer to critical infrastructure than regular mobile phones. And when it comes to development speeds, mobile software is very much pushing the boundaries with agile, DevOps, and any other means possible. Infrastructure systems emphasize safety, reliability, maintainability, process conformance for understandable reasons. Automotive industry wants or needs to be in that left column with feature development speed. So as you can see, modern automotive systems, modern automotive software systems check every box on the list of how to make maintenance hard. There are millions to billions of highly connected, highly complex systems that cannot be easily accessed for maintenance, to be kept safe for a very long time, while pushing out new features faster and faster. So that's why our challenge is different. There are practical solutions to help manage this challenge, and we have collected some of our best learnings and practices here. Based on our experiences, automotive development projects still often follow the topmost project model. The project's aim is squarely at the start of the production and sales, and that's when the product needs to be ready. There may be a more active update phase at first, with fewer and fewer releases the further we get, and then being ramped down to just the critical fixes. The first thing to change is the mindset and the project mode. Instead of separate pre-production development, update, maintenance phases, we should end up with one very long development project with preferably regular and frequent releases. The project will, of course, get smaller over time, but the model should remain. The reason for that is that in this new highly connected world, the vulnerabilities can happen anywhere and anytime. Often the older systems make better targets than the new ones, so they need just as much, if not more, attention. Also, the need for rapid response in case of a hack in the wild remains the same over the whole product lifecycle. So ramping down the development activities early is much bigger risk than before. Let's say that we've changed our mindset on our project model. Now we can build on that change. The basis for all the rest is having maintenance as part of the product planning from start to finish. Create a maintenance strategy or a plan early in the project and keep it always up to date. This could outline, for example, the foreseeable upgrade plans for all components and systems, possibly even different upgrade paths for different cases. The most important characteristic for this plan is to be flexible and adaptable. And there's a simple reason for that. We can't reliably predict, or to be totally honest, we can't predict at all what kind of bugs and vulnerabilities will be found in the future, when they will appear, what kind of impact they will have, and which components need to be modified to neutralize the impact. As an example, you can't really plan for something like the Spectre vulnerability and the very easy remote exploits appearing with that made nearly all the CPUs in the world suddenly vulnerable almost overnight. So there is no pre-planning against something like that. So the objective is not to prepare for everything, but to prevent any short-term decisions making needed future corrective actions super difficult and super costly. The next solution is a system architecture that enables updates and maintenance. One part is the previously mentioned over-the-air update. Planning system modularity carefully is just as important, if not more so. Modularity can help any incident response in two ways. With security, it can limit the impact of a possible hack. It can also enable updates for smaller subsystems, so you'll get more reliable, smaller and faster updates. And there are various solutions for this modularity, such as separate hardware units, virtual machines, containers, well-defined interfaces and components, and usually the systems use more than one to reach their preferred architecture. Good code line management and DevOps practices are critical so that you can push out good quality releases repeatedly, possibly across a large number of product configurations, especially with the strict process requirements of the automotive industry. This is an area that has seen a lot of progress lately, and it's also an area where we have done a lot of work in various industries. There are some important considerations for the automotive area, though, and that rapid progress is one of those. The DevOps tool development is a highly competitive area at the moment, but that mostly focuses on adding new features to these tools and maybe carving space from competitors' territory, not so much about the very long-term support capabilities. And in general, dependencies and build and runtime environment compatibility issues are not only for the evolving product software, but also for all the tools used in the projects to build, test, release, deliver the software. One clear example that has come up in several tools are the different limitations in version management. Just a little details where versioning is not actually covering everything. You may have a version management in most of the things that you do with the tool, but then something links to only the latest version, breaking basically everything. And this can go through multiple links, multiple connections before it's actually noticed. So, but this is an example, practical example of something that has happened actually several times. So this goes directly back to the maintenance strategy. Do you always move old projects to new tool versions, or do you prefer to remain with the old tool versions and maintain yourselves? Well, as with everything, it depends, but be flexible. Which leads us to the next solution. One of the ways to manage this process easier is to rely on partners and suppliers to handle certain parts of your long-term strategy. Operating system maintenance is one area. DevOps tools is possibly another area that can be bought from a partner. The typical maintenance project for, let's say, a no longer supported Android version, likes of which we've done for our customers, might contain backporting fixes from newer versions, implementing other fixes from scratch if there isn't one available, or then the delta is already too big for backporting, monitoring vulnerabilities, and possibly also evaluating transition to a newer version of Android versus maintaining the old. And this frees up the customer's resources to focus on their core business features. It's always worth asking yourself if your core business is maintaining operating systems and tools, or if that's better left for someone else. The last solution area I want to touch in this presentation is not just about software, but rather hardware dependencies in software. The solution is simple. Keep hardware as part of the software maintenance strategy. The hardware component availability over the whole planned product lifecycle is already today carefully managed, usually, and part of the processes. But what about the software needed to use that hardware? It's much harder to nail down specific software requirements for hardware. Drivers and board support packages need to be compatible with the rest of the environment, the software environment. And that environment is realistically going to be a moving target. The basic ways to manage hardware-software dependencies in the very long term are exactly the same as with software dependencies. Up-to-date adaptable maintenance strategy, solid modular architecture using well-defined interfaces, and good use of suppliers. Some of the types of issues you might consider here are, for example, driver support and hardware replacement. Driver support means having working software drivers for every piece of hardware in the product linked to an evolving software environment. So what happens to this driver support if you need to select maybe a new kernel version 5, maybe 10 years into the project? Source access to all drivers is one method, but even that might not be enough, as sometimes a deep knowledge of the hardware internal functionality might be required to port the drivers. And in some cases, software maintenance just isn't feasible solution. Sometimes the needed changes in the software are big enough to obsolete even the hardware. The two extremes in managing such a scenario are the traditional model and the Tesla model, or I would call them traditional model and the Tesla model. Traditionally, major hardware changes are something to avoid almost at any cost. Those hardware changes erode badly the already slim margins of new cars. The Tesla model, however, sees this new hardware revision more as a business opportunity to sell new features to old cars. So again, be prepared to adapt. So that's all the material I have for this session. If you want to study our ideas further, please follow the links to our blog and white paper on this subject, and we can continue with the Q&A session.
Fantastic, thank you so much. I'm actually going to ask, I was going to grab the presenter right away from you, but I'm going to ask you to go back to the slides with the strategy. So not this one. Let's stay on the next one, where you got the 4.
This one?
Yeah, this one. I have so many questions on this. But you also, the very last bit where you mentioned the traditional model and Tesla model is also something I want to touch on. But let's start first from the bigger picture, in case there's someone online who's not fully on board with all of the software and hardware architecture that we're talking. When you say strategy and the management, are you talking from an OEM point of view or from a software provider point of view?
I think that sorry.
Yeah, so who is the one who has this strategy?
At the moment, it's the I would say the OEM, but of course it's the party which has the product basically. So if you're selling a product, if you're let's say a tier 1 supplier and you're selling a product to OEM, then you should have one yourself. You can have a platform that you're selling, or if you're a software partner who's selling this, let's say an operating system component, then you should have that. You should be able to support that for 15 years, so you're in the same position. But in the first at the first, let's say, level, it's the OEM. They have the product, they are responsible for the car being safe. So that's the first level. Then it comes down from there to should come down from there to all the partners.
Yeah, let's take a concrete example. We got some good news. I think it was last week. Ford announced that for their F-150 pickup trucks, which is the most sold car in the US, a Finnish company, Rightware, their infotainment systems are going to be in those Ford pickup trucks. So in that scenario, Ford needs to have a maintenance strategy for Rightware software, but also Rightware needs to have a maintenance strategy on how they support Ford.
I think Rightware software needs to be part of the Ford's whole software strategy, so that I guess this is one of the issues or one of the challenges is that once you start splitting up the complete software package, which is the car, and the hardware that is linked to that, then you start creating the kind of, let's say, you start creating these kinds of possibilities to paint yourself into the corner. So all of these should have a strategy on how to handle all the software in their car. And as one part of that, yes, there needs to be sort of the rightware, that they agree with rightware, or they plan themselves and then tell that to rightware, or plan with rightware that, okay, how are we going to handle this for 15 years? Yeah. Your software is going to be in our cars for 15 years. How is that going to happen?
So on your picture here that we're looking at, maybe so this is the Ford strategy, and the outsourcing part is the rightware's piece, where they are responsible for keeping their software up to date.
In this specific case, it would be the Ford which would need to have this understanding, and of course probably it would go to rightware, and rightware would tell them, okay, this is how we can handle the 15 years. But in case of rightware having a platform that they can provide to multiple OEMs, then they also need to have this idea of how that works. But in the bigger picture, it has to be the product, let's say product owner, the product manufacturer.
Okay, and I'm sure both of these companies have all these pieces. I was just using it as an example. Yep. I love what you just said, the complete software package, which is the car. So you're viewing the car as a software package that just has hardware come with it. Earlier, you've worked in standards. That's actually how we met. I was writing down when you were talking about standards, like what you talked about all these different operating systems. But if we look at the car as an operating system, do you see at some point that it's possible to standardize the car, quote unquote, operating system? So there can be like update management strategies that are similar across the board on different OEMs. And I came up with this question before. You said there's a Tesla model and a traditional model, but what if there was a third model, which is like this interoperable standard model?
There have been sort of tracks going that way. For example, the GenEV is one that where the work was started by BMW, and I think we had Land Rover was there, Jaguar probably was there. There are other OEMs also taking part there right now. Also, this automotive grade Linux was one, but those are like, let's say, I don't think there is one operating system that can run the car. So even though, for example, Tesla seems to be using a lot of Linux, there are places where you can use Linux, there are places where you can use AUTOSAR or adaptive AUTOSAR, and there are standard solutions for a lot of those. And then there are pieces where any operating system might be an overkill. So I think that every OEM probably will have their own idea of what kind of a combination of these systems they will have, and they won't have one running everything in car running on Linux, for example. It probably doesn't make sense at least with our current level of technology. So I would say that it will always be a combination of different types of operating systems or even embedded software communicating over common technologies like IP, Ethernet, automotive Ethernet, and so on.
Do you see a risk? So it's understandable that OEMs want to differentiate themselves from their competitors by using different types of software platforms and combinations. But you also talked about safety and privacy is a big concern, of course, to everyone. So people might be afraid that the OEM is collecting information about where they're driving, how they're driving, etc. If the OEMs are using non-standard operating systems. Do you see this as a risk in some way?
I think that it is a big sort of issue to tackle, definitely, that who can get access to the drivers or passengers as well data, and I think one of the areas there is that we are moving towards more and towards not just collecting information on your playlist on your infotainment screen or your location even, or your routes. We are moving towards sort of sensing maybe health characteristics of the people in the car, or who's in the car, and of course this kind of cameras will be inside the car as well as outside the car, and this is definitely an issue. But I don't think the operating system is going to be the deciding factor there. Operating systems can be used to collect data unless they are really locked down, and I really don't believe we are going to go to that. So operating system is not the issue. It's let's say a policy issue of what kind of permissions you need to get for certain types of features, and for example, the GDPR is one example of the data being there, but you just can't use it because you don't have the permission of the user to use their data. So this is definitely a big issue. I think this is also one of the big sort of, I wouldn't call them battlegrounds maybe, but these issues are popping up everywhere, that who actually owns that data. How can we make sure that, for example, the user owns the data, or that the OEM owns the data, or then for example, the operating system vendor owns the data. So who gets that?
Yeah, that's a very interesting point. Another thing I noted down is you said maintenance first type of software development. Those of us who were in telecommunications, we remember when everything was mobile first. So now we're entering a new era, which is the maintenance first in car software development. That reminds me of, you talked about the cost of development, and one of the things that is an outcome when we look at the cost of development is there's a real risk at some point that companies run into this technical debt if you don't, you don't take this maintenance first approach. And one of course, a really huge issue that was in the news was the Boeing 737 MAX issue, which was, I think it was a technical debt issue. Do you see this happening in cars? That is there a danger that OEMs are going to be piling this technical debt, could become a safety issue?
At the moment, I don't think that that's the biggest risk right now, but it might if there is going to be a big change towards moving faster and faster, and there aren't any sort of, if you don't have the skills, or you don't have the people, or you don't have the processes to actually execute that, then the technical debt you will get a lot of that. But I think that right now we are still at the sort of era of safety first. So the solutions need to be safe, and if that means postponing some vehicle launch dates, then at the moment it does happen. Well, how that will go on, I don't know. For example, of course, I don't want to. Let's put it this way: I don't want to say a bad word about any of the OEMs, because they might be our next customers. But you have this constant, let's say, competition between, or constant conflict between trying to move as fast as possible, or trying to guarantee that your vehicle is safe. So what is the sort of reasonable level of accidents that you can have, for example, when we are talking about autonomous driving? So is the reasonable number 0, or is it less than what is happening at the moment? Is it better to have something that causes less accidents than what we have now, but still does cause them, or do we have to wait until we are at the zero accident testing level? And I think that that's also one of the areas where there will be, or there needs to be, some sort of an ideological or process change that let's say that good process doesn't guarantee a safe product. In some other areas, testing is the thing that proves that something is safe. In some ways, in some cases in the automotive, it's more like, do you follow a process that ends up as a safe product? And this is getting sort of harder and harder to follow a process that would guarantee that the product is safe when you add extremely complex software components like tens of millions of lines of code in a Linux kernel alone. So when you get to that kind of complexity, you can't have a process guaranteeing safety. You have to have a lot of testing. You have to sort of rely on testing rather than, and possibly sort of usual ways of handling this with the duplication and so on. But
the code line that you showed earlier, you had often release early. So what you're just saying is, okay, it also needs to be safe. So there could be maybe not a contradiction, but there could be a challenge there.
And this is all again going back to the modularization and going back to this sort of DevOps, that you need to have automated testing for those releases as much as possible, but you also need to be able to sort of release some things that are not touching the core functionality of the car. So these are the kinds of things that are why there are no. I'm not pushing for a new process or a new tool to solve the problems, because everyone will have different set of problems. But the idea that you have to have testing, and you have to have testing as part of those releasing, often the releases that will be happening frequently, and also the modularity, so that the core parts, the important parts for the safety, you try to keep your hands off of those. So those are not released, but you need to be able to release everything around those pieces safely.
Yes. So you're saying, for example, the diagnostics on control or diagnosing your brakes or oil systems in the car versus updating your satellite radio software. So those are
definitely. That's I think the most critical decision to make is well, how do you make sure that the things that keep your car safe and the things that keep your car secure, you don't need to touch those unless there is something badly wrong. Then you might get something like Spectre and all bets are off and you have to fix that. But in the usual case, you shouldn't touch the most critical pieces. You shouldn't have to touch the most critical pieces.
Yes. So we're getting towards the end of our time. I want to go back to the privacy issue. So you mentioned early on, you said the digital lifestyle of people is affecting how cars are being built. So people expect these software updates. We have an audience question, and this came when we were talking about privacy and who owns the data. What if the driver has to access the license terms and data collection before they can start the car? Kind of like a breathalyzer for data collection.
I think that then we would need to have a very good UI design to make that easier. But yeah, I think that it would be something. We already have a lot of these things. For example, the license information is there somewhere. It's there, but it's there somewhere in the menus in many cases. So I don't think I don't think you will be selling many cars if you say that, okay, here are our cookies, accept them, or go through this multi-page licensing agreement before cookie agreement before you can actually start your car. So I would say that comes back to this sort of customer value with the product, that you have to make the car isn't free, let's put it that way. Someone is paying a lot of money for the car or the ride, and so that creates a certain level of expected usability from that. Unlike websites that we are basically using where for free or with the ads.
Okay, I think we need to start wrapping up. We're over 45 minutes already. I'm going to give you the final word, Markku, on the traditional model and the Tesla model. Do you see the Tesla model, so being modular, also selling not just new software, but new hardware, OEM seeing that as a business opportunity? Do you see that taking up with other OEMs, or do you think that Tesla is alone in this thinking?
I don't think anything right now points towards there being any other choice. The development of the systems, the different chipsets, and the speed of development at the moment, I don't think there is any choice in that area really. So you have to be able to upgrade your hardware, or your car will very soon become obsolete in the marketplace.
That is the perfect ending for the session today. Thank you so much, Markku. Thank you all of our attendees. Thank you our one speaker, Markku. As said, the session was recorded, and the recording will be made available to you. We'll be posting that on our YouTube channel and send the link out to you. Thank you, everyone, and you have a good evening or a good day wherever you are. Thanks.